Today, I'm going to talk about moral and ethical aspects of using AI systems. Why is it so relevant, especially this year, as I think? Because a number of countries in Asia using AI systems have coped with the epidemic quite successfully. But not only because they were developing medicines or they were doing more effective diagnostics, but also because they were controlling the population. They were using machine learning algorithms to control the population. But to start with, let me explain, to put a little dot on top of I, what AI is. To me, for a practitioner, for a developer, AI is in the first place about ideas. The ideas that drive and push the entire industry of machine learning, and this has been happening for more than half a century. And in the past decades, all the successes have been a result of a very simple idea: the desire of the humanity to teach a machine think. So artificial intelligence realizes itself in the real world through machine learning algorithms. So you take servers of companies just like in Google data center. These algorithms recommend us music, movies, enhance our pictures, our photographs, allow us to find any information in seconds. But sometimes these algorithms make mistakes, and they don't just make mistakes, but when it comes to making decisions about real people, or by real people regarding some social and demographic groups, the algorithms make such mistakes that you may no longer treat this mistake as a mistake. It becomes a bias. So the algorithm does not only make a mistake prediction, but actually making a bias prediction. So what is it? What kinds of errors are we talking about? Well, they are well known. You can find them using the links. The first algorithm was from Amazon. That algorithm made HR people's life easier. It would just look for candidate CVs, and if there was a female club or a female reading club notice, the algorithm would filter such a CV out. Amazon stopped using this algorithm. When it happened, the data had been used for the past 10 years. In the past 10 years, technical position weren't that popular among women. So the second case, very well known. You can find it following this link and it's a detailed analysis of this algorithm. That was a COMPASS algorithm that it was used to improve the penitentiary system in the US. Of course, you can imprison everyone, but you can assess for each criminal, like when a person has already committed a crime, you can assess the risk of repeat crime and the heaviness. So it turned out that this algorithm would assign a high risk to dark-colored people. Another case. This comes from today. It's more controversial, but I think a lot of you have encountered voice assistants. And I have friends who speak Russian very well, but nevertheless, they had some difficulties talking to these systems. Let's take a look at a short video.
interactions in the last 12 years in the US did not mirror the same linguistic experiences I was having in digital spaces. Calling a bank and getting an automated teller would be a frustrating experience, as my letter A as in apple was often heard as E as in echo. So you could imagine, as I tried to spell out a name like Halcyon Lawrence, I wouldn't get very far. There was simply no room to dance with the device when it could not hear me. Even if an American listener didn't understand me, there was always room for negotiation. Yet in the digital, none of my clear speech strategies worked with these devices. Slower, louder, and hyper-articulated speech was often mistaken by digital listeners as angry or distorted speech. And so it began to dawn on me that in digital spaces, I was not being heard.
Let me comment for those who may have not understood this woman. She actually has quite an interesting accent of the English language. So her problem was that machine learning algorithms, these bankings, voice assistants, would not understand her. And if she were trying to use the tricks that she was using when talking to people, the algorithms would assign an increased aggressiveness to her. So it's just an example of accent-based discrimination. So, in one of the presentations, I encountered a statement, quite serious actually, saying that getting people rid of a bias is more difficult than algorithms. Well, I know that to make an algorithm run well is not a simple task, but you need to make a model that does not only work well but also work fairly. But in order to make a model work fairly, you have to give a mathematical definition of fairness. The simplest understanding of fairness and the formalization of this concept there are several of those in mathematics. It has been proven that they're all equivalent. One of them is the outcome of the machine learning model should not depend on the sensitive variables, sensitive data that we can feed at the input, that gender, age, race. In fact, there are quite a lot of such sensitive variables. And I'd like to bring your attention to the open source library developed by IBM that brings together the most frequently used and most popular algorithms or tricks to make your algorithm fair. How to teach a machine to be fair. Actually, you can ensure that your algorithms are solved at all the stages, pre-processing. If we have data about people, some kind of data, we can not only do something with the sample, do some resampling, but also using some linear transforms, we can put data in a new space, the result of which will be that the model will no longer depend on the sensitive variable. It could be done at the post-processing phase. So you can set a threshold in classification problems. So the model does not just say 0 or 1. It offers you the probability of the results being 0 or 1. So you can actually smooth out the distribution between the groups of sensitive variables, like between men and people. Of course, the most interesting cases are those when we are trying to make the machine learning algorithms fair and just during the training process, learning process. Adversarial debiasing. There's a model. We teach it to predict our target variable y, and at the same time, we are teaching this model to make a prediction regarding our sensitive variables, to make so that the model should give very good answers about our target variable, but would give very poor predictions of our sensitive variable. And this approach ensures that the model is trained in such a way that it doesn't depend on our sensitive variable z here. But all the methods offered, as you may have noticed, have a big drawback. We have to know what these sensitive variables are. For instance, a problem recognizing a person in a picture. And we just have a selection of pictures. There's a human face, and they're marked with zeros and one. One is when there's a face, and zero when there is no face. But we don't know anything about what's there, what kind of material is in those pictures where human faces are. We don't know how they're classified in terms of skin color and so on. Here we are getting variational autoencoders involved, and everybody understands that within such a model we get an internal latent data representation. We can filter out those features of source data that are not very representative in our teaching selection. So it looks like everything's cool. There are lots of algorithms, they all work, but there's one big drawback. Every time the humankind has been implementing a new machine learning or decision support system, it would only understand the biased character of the model operation after some time of using the model. And it looks like the humankind can be stepping on the same rake all the time. And here, let me remind you that AI is an idea in the first place. Ideas can be rethought, can be given new meaning, and this is happening all the time. It's an integral part of any idea. But now I see three areas where the rethinking of what fair AI is could develop. The first step is that the digital humanities. It's a multidisciplinary speciality when philologists, journalists, humanities people are taught machine learning so that they could work with them direct doing their job. But the second area of rethinking is about regulatory environment. To me, it's quite obvious. If the government is passing its controlling functions to an ML algorithm, it of course has to be regulated. And the third area is the democratization of AI. Here I love two ideas. One of them comes from the West, when people, groups of people who noticed something unfair in the algorithms that apply to them, they get together, they improve the code, make some actions. But the second initiative comes from Russia, I'm part of it. It's a master's. It's about collecting the tasks from government bodies. It's about collecting data, openness of the code and openness of the data. So openness is one of the solutions to the problem. Thank you very much for your attention. I'll be happy to take questions. Dariana, thank you very much. You've touched upon a very interesting topic, and we haven't yet arrived at AI from this perspective, and frankly, I hadn't even thought about this. Well, of course, it's kind of a philosophic notions, bias, but how do you think? Biased or unbiased models? Well, it's a human that judges whether it's biased or not biased. Another question is whether they're not biased themselves, I mean the people. But when will the machine become able to do self-diagnostic? Well, I've just given you example with autoencoder. This is exactly this case. It's where the machine itself, but that's a solution relevant with reference to the input data. But in actual fact, yeah, it's not really a philosophical notion. In the Western society, it's legislated, so, I mean, it can be just absorbed.